Okay, option D, I got one answer. Let others also to solve. Take your time and re-verify whether it is correct or not. Okay, I got two answers. Re-verify whether which is correct. Okay. Take one more minute. After that, I will give the solution. Okay, I got three different answers B, C, D. Okay, we have to see which is correct. Try to check whether which options is correct. Re-verify your answer. Take one more minute and re-verify whether your options is actually correct or not. Okay, I got three different answers for the same question. Okay, let me give the solution for this. So, in the question, it is said that a constant impedance load is there, and which is consuming 2 kilowatt at a rated voltage. And it is saying that if the feeder voltage drop to 0.95, what is the new load becomes? Okay. So in this problem, when you see if we draw the SLD single line diagram, so it is simply like this. You have a transmission line like this, and there the load is connected. Okay, so I assume that this is the bus A and this is bus B. Okay, so if the feeder voltage drop, so I consider this as a feeder, so voltage drop VA VB. Okay, so VA minus VB, that is delta V, this is basically equal to 0.95. Okay, so this is 0.95 pu. So it is asking new load what it will become. Okay, so when the voltage drop is like this 0.95. Okay, so when you see the problem here, so power is basically V square by A. Why? Because it's a constant impedance load, constant Z load. Okay, so the power is V square by Z, and the Z is if constant, so power will be proportional to V square. Okay, so initially let's consider that it's a 1 pu, uh, when there is no feeder voltage drop is there. Okay, so the power when it was coming, it was 2 when it was 1 pu. Okay, and let's consider x when it drops to 0.95. Okay, so it's a 2 by x is equal to 1 by 0.95 of square. Okay, so you can calculate x from here, it will come out to 1.805. The correct answer is option B. Okay, just you have to see few lines here. Suppose here it is given already that it's a constant impedance load, so you just have to click in your mind that it should be proportional, power is proportional to the V square in that sense. Okay, so after that you will get the correct value, what is the power which is being able to transfer. Okay, try to solve this. Okay, I got one answer, option B. Okay, check again, check again. Okay, I got as option D also. Okay, so re-verify whether the D is correct or B is correct. Take your time and try to solve. Okay. Okay, actually option C. Okay. Um, Take one more minute and rethink whether option C is there or option B or option D. Take one more minute just. Okay. Okay, let me give the solution. So here when you see it is saying that a feeder is operating at 11 kV, okay, and it is upgraded to 22 kV. If the allowable percentage voltage drop remains the same, load is unchanged, and the maximum feeder rate can be increased by the feeder. Okay. So there is a one concept that when you consider the load ratio and the distance ratio, this is equal to the V new by V old of A square, or you can say that distance multiplied by load, okay, is proportional to V square. Okay, so it's a just that key whatever the power you have seen in this problem, when you'd seen the previous problem where power was proportional to V square, okay. But this power is actually proportional to the load and how much distance it have to be traveled. Okay, so this ratio is considered, but the load ratio is given 1, so distance ratio is proportional to basically V square. So in this sense, it is said that this is proportional to, it became the 2 times. Okay, so in that sense it will become 4 times. And there is other way to understand also. Suppose you have a generator here, and you have a feeder, and you have a load in. Okay, so it is a feeder is operating at 11 kV and upgraded to 22 kV. So I'm considering there is no voltage drop here because it is already being saying that there is a voltage drop, but it is constant. Okay. So if I consider here, this is VA and this is VB. Okay. So the power which is traveling from here to here, it is basically in the power system term VA by VB by X sine delta. Okay, or you can say VABB is constant. In that sense also, the I'm considering no voltage drop, or it will be same, power is proportional to V square, but this X is also proportional to length. Okay, so that's why the loading criteria, the L multiplied by P is also proportional to V square, considering L delta is constant and L omega is constant. Okay, so in that sense, it is proportional to V square, and the maximum feeder rent must be increased to accommodate that kind of voltage level. So that is also became 4 times. Okay, so this is another concept to understand. Okay, try to solve this problem. Okay, option B, I got multiple. Re-verify whether it is correct or not. Okay. So in this problem, let us see here. So the three-phase load of 660 kilowatt is supplied at a 11 kV and 0.95 power factor. Okay. So this problem I have given just to make you understand that few equations like root 3 VLIL cos phi. Okay. Or you can say 3 VPH of cos phi. Okay, so these are the few factors. Okay, so these are the few equations which is important. Also you should remember that power is equal to s cos phi, q is equal to s sin phi, and also s is equal to root p square plus q square. So these are the important formula you must know. Okay, so here it is given already 660 kV, and it is root 3 VL is given 11 into to the power 3, IL is being asked, and the power factor is zero point 0.9. And when you try to solve, it will come out to be uh, how much? I think option B you already given. So 38 amps it will come. Okay. So this is the just a basic formula, but it is important to understand. Here one important thing also you should see 11 kV. Here it is not given the phase or the line, whether it is a line voltage or whether it is a phase voltage. Okay. So, but its voltage when you see it's a 11 kV. 11 kV is only transferred to the three phase system. Okay. 415 volt, it's fine, it can be a single phase system, or you can say it's also three phase system. 230 is a phase, single phase you can transfer. Okay, so 11 kV when you see these much high voltage, so it's a by default a three phase system. Okay, let's move further, try to solve this. Okay, option A and B, I got one answer, and option A also I got. Okay, okay, let me check. Okay, so it is being asked that which demand side management shift the electricity used from the peak to off peak. Okay, so you just have to understand what is the different concept here: load shifting, load shedding, load forecasting, reactive compensation. Okay, load shifting, it is correct answer. That is fine. Okay, because when you have the different, this is the major. Okay, this is the morning peak and this is the evening peak basically. A- and when you try to shift, suppose this is the peak and you wanted to shift to some other time, so this peak, this whole will come here and it will increase. Okay, so this is called as a load shifting. Okay, okay, so the option A, it is asking that which method shift the electricity use from peak to off peak hours. Okay, so this is called as a load shifting. Okay, so load shifting, uh, so this is the A is the correct answer. But when you talk about the load shedding is basically you are not shifting anything, you just reducing this whole power. Okay, you just reducing, suppose you wanted to curtail it and you don't want to used in the other time frame, that is not being correct. Okay, so this is a kind of load shedding, and this is not advisable during the operation of a power system. Okay, during power system operation, the your system should be such that the load shedding will be a last resort. Okay, and the load forecasting basically predicting what will be the behavior after some time. Okay, and reactive compensation is to provide the reactive power support when it is required. Okay, so correct option is option A. Let's move further, try to solve this. Okay, I got multiple B options as a B. Okay, let's see. A outage always result in interruption of a supply, that is true. Okay, when you talk a outage refer to the non-ability of a operation of a certain equipment. An outage always result in the interruption of a supply. Okay, let me see whether it is correct or not. Okay, let me re-verify. Which of the statements regarding the outages is are correct? Okay, so an outage always result in the interruption of a supply, but that is not a case, because when you have a multiple generating sources, okay, so one supply can be off in a certain duration, but other systems is operational. You just have to trip the circuit breaker of that generating sources, and then you can supply from the other sources also. So it result in the interruption of the supply, but not for a sustained time. Okay, an outage refers to the non-ability of a operation of certain equipment. No, or you can say that, okay, when the some generating unit is not operational for a certain duration of time, that is called also called as a outage. Okay, a force outage occur due to the emergency condition. Okay, that is true. The force outages basically comes when it is a some scheduling is there. Okay, some maintenance is required in that situation. You, and also certain fault comes and you wanted to trip that phase, in that situation also that force outages can be done. Okay, a scheduled outage is carried out for the preventive maintenance. Okay, that is true. So okay, so this is correct. So an outage refers to non-availability operation of certain equipment. Okay, that is also correct and that is also correct. Let's see what is correct. True, true, true. First is for outages may or may not cause interruption if one trans. Okay, so first option is not correct because it can be other transformer can also supply or other generating sources also can supply during that time frame. So option B is actually correct. Okay, let's move further. Try to solve this. This is a little bit lengthy problem, and I have given you the some glimpse in the previous tutorial session. Okay, you just read it out and try to solve the first first problem first, option A. Okay, try to solve the part A first and let me know which is correct. Read thoroughly the problem. If you're not able to understand the problem, you can also tell me. I can give you some basic idea to how to solve that. Okay, I got one answer, option A. Okay, okay, that is, I got more. Let's wait for one more minute. Let's other also to solve. Okay, last 30 second. Okay, those who have solved the part A, try to solve the part B. Okay, okay, let me give the solution for the part A. Those who have solved the part A correct answer is, let me see, correct. Okay, 0.84. Okay, uh, listen here. So, those who have not able to solve the part A, So it is said that this is one important statement given here ki given information assumption of the independence. Okay, so when you see the independence equation, so this is basically a intersection b, a intersection b c is basically pa multiplied by pb multiplied by pc. Okay, so when the occurrence of a one event is independent of the occurrence of the second event, you can multiply, and when it is an intersection pass you can multiply the terms. Okay, and it is said that ki probability, the reliability, or you can say the probability, it's a operation of a first a unit is basically zero point 0.9, and of a transformer b in the operation is their probability is basically 0.95, and when you see about the of it, it's a third unit, it's a 0.99. Okay, so probability of having no failing transformer. Okay, so it means that ki all the things should be fine. Okay, so so in that scenario, when you multiply with the pa pb pc, let me multiply 0.99 multiplied by 0.95 multiplied by zero point 0.9. Okay, so it will come out to be, so it's a multiplying by zero point 0.9 multiplied by 0.99 multiplied by 0.95. It will come out to be 0.846. Okay, so this is the correct answer for the first option. If you still have a doubt, you can ask. Okay, otherwise try to solve the second part. Okay, I got answer. Part B is 0.0945, 0.04455, and this. Okay. I request others also to solve. Okay, so it will be good understanding of this equation. So try to solve the third part if you are able to solve the part B. Okay, and the answers are basically zero point 0.09, zero point 0.04, 0.0085. Okay, so this is answers are correct of the part A also, part B also. Try to solve the part C. Okay, those who are not able to solve the part B, listen here. So in that scenario, it is saying one of the out of this transformer is filled at a given time. what are probability for that the unit being the transformer A or B or C. Okay, we don't know whichever that which was the transformer which went out. Okay, so it is basically like this: probability A which is not operational, B is operational, C is operational. Or you can say probability of A being operational, B is not operational, or C is operational. Or you can say probability of A is also operational, B is also operational, C is not operational. Okay, yeah. So in this first part also you just have to take the PA, because it's a bar, because it's not operational, so you will take 1 minus PA multiplied by PB, okay, multiplied by PC. Okay, similarly in the second part what you have to do, probability of A multiplied by 1 minus probability of B multiplied by probability of C. Okay, similarly you have to solve for the third also. Okay, try to solve the third part of this. Okay, I got one answer. Okay, okay. Others also try to solve. No? Okay, I got the same answer. Okay, most probably it will be correct only. So it is 0.00495, 0.0095, and 0.0045. That's correct. Okay, try to solve the part D. After that, I will give the final solution of the C and D. I request others also to solve. Okay, solve for part D. Okay, part D 0.0005. Okay, others also I request to solve. I got one answer of the option C. Okay, that's correct. Correct. Okay, try to solve the part D. Take one more minute and try to solve for the part D. Okay, let me give the solution for the part C and part D. Okay, so in the part C, it is telling that ki if the two of the three transformer fails at a given time, what is the probability for those unit being the transformer A and B, B and C, or C or A? Okay, so it's like this: probability of A intersection uh, A is not operational, B is also not operational, C is operational. So it's something like this: probability of A, 1 minus probability of B, okay, multiplied by the probability of C. Similarly, like this also, okay, when the B is not A, B and C are not operational, so it's like this, okay. So and also when the C and A is not operational, so it's like this: A intersection B intersection C, okay. So it's like this. So you have the three equation for the same, and you just have to put the values, okay. And for the part D, it is telling that when the having all transformer out of service, you just have to take the probability of A bar, because A is also not operational, B is also not operational, C is also not operational. It's something like this: ki 1 minus PA, okay, 1 minus PB, okay, 1 minus PC, okay. So these are the basic methodology to solve this problem, okay. So these are the answers which is already given, okay. Try to solve, let's move further, try to solve this problem. This is reactive forward support from the capacitor bank. Okay, let me give the solution. Okay, so I got one answer, option B. So in this problem, it is saying that you have a synchronous generator which is rated as a 1000 kVA. Okay, S is given as 1000 kVA. Okay, and it is operating at a full load at zero point 0.8 power factor lag. Okay, so it's operating as a zero point 0.8, and what is the power factor? Basically, power factor is zero point 0.8. Okay, an additional load of 120 kilowatt at a 0.75 lag got added, and determine the capacitor rating is required to not get overloaded. Okay, so when you see this problem, this is having a certain power which is already there into the system, which is being consumed, and it is lagging. So you it also have the some reactive power also going into that. Okay, so this is power, this is Q, and this is the zero point 0.8 lag. Okay, then it is telling that you got again some value, some additional load into the system. So this is like this, plus 120 whatever was there initially, and then you got the added the 0.75, and it was at the power factor, so it is also having a some reactive power. Okay, so final when you see it having a some P which was already there plus 120, and it was having a reactive power which got added up. Means it was, suppose the Q was there initially and Q dash came into the picture, so Q plus Q dash is required. Okay, so but here is the problem that key S is fixed. Basically here S is 1000, which is equal to P plus 120 of square plus Q plus Q dash of square. Okay, but in this situation, you need require a capacitor bank also, like QC, to reduce this Q plus Q dash to make that this is the 1000 kV only. Okay, so it should not get changed, it should be constant, and that constant nature is coming from this minus QC part. Okay, so when you are adding certain part, some power or some reactive power from the external sources, which is being reflecting here to make the 1000 as a constant term. Okay, so what you have to do, you have to just find out what is the power. Power is basically 1000 multiplied by S multiplied by cos phi. Here it will come out to be 800, so this became 800. Now you have to find out Q. Q is basically multiplying with the sine phi. Okay, so this will come out to be 600. 1000 multiplied by zero point 0.6, it will come out to be 600. Now you have to calculate the Q dash. Q dash you can calculate from here because the power factor is already given. Okay, Q is basically P tan phi. Okay, so when you find it out the Q dash, just put in inside of the equation, find out what is the value of QC, and when you try to solve the QC, it will come out to be 313.91. So option B is actually correct. Okay. So here you just have to see what is actually being called as a constant, and what is the parameter which is being changed to make that constant as a constant. Okay. So that is important part. Okay. And also remember this kind of phasor diagram you should, if you are able to draw, so it will be easy to solve the problem. Okay, let's move further, try to solve this easy problem, but I needed one solution from this. Okay, option B, option B, option B. Okay, so that's correct. Okay, it should be 1 minus n minus 1. Okay, that's correct. Try to solve this problem now. Easy problem we have solved in the last tutorial session. Try to solve again. Okay, option A. Let's other also do solve. Okay, option A, option A, option A. Okay. Let's wait for others also for giving 30 second more extra. Okay, let me give the solution for this. So in this problem, it is being asked that you have a PV panel which is rated to 50 watt and the 25 volt. An array is required to supply a 20 amps and 200 volt. Okay, so we already know that we connect the panel such that to follow the required voltage, and also then we will connect in such a manner that current should be delivered to that amount. Okay, so when you see here the PV panel here, one module is basically 250 and what is required is basically 200. So 250 25 volt and it is required to 200. Okay, so number of panels which is connected in series, okay, that is equal to 200 divided by 25, that is come out to be 8. Okay, but here when you see the current required here is the 10 amps. Okay, what it is delivering 250 divided by 25, it is giving 10 amps. But what is the required current? Required current is basically 20 amps. Okay, so now you have to connect the same 8 configuration because voltage you have to maintain and you have to increase the current also. Now you have to make it two string. Okay, if you make the two string, the current which is flowing here is the 10 amps, here the 10 amps, so overall current which you get is the 20 amps. So it will be 8 multiplied by 2 is equal to 60. Okay, so correct answer is the option C. Okay, so you just have to maintain because you are having a certain module, you have to connect in such a manner that it should satisfy certain voltage requirement. Okay, so this is coming out to be 200 volt, and then you have to make the make sure that ki same current what is required to be delivered. So we make the two such system to make the current to flow at 20 amps. Okay, so it will come out to be 16. So 16 is the correct answer, option C. Okay, let's move further. uh, uh, Remember this problem, this is important and you can expect one of the question from here. Okay, try to solve this is an easy problem we have already seen in the previous tutorial session. Try to solve this. Okay, I got other answer true, false, false, false. Okay, okay. Huh. So in this problem, let me give the solution. So this is basically saying the option A, microgrid are decentralized energy system that can operate independently or in conjunction with the main grid. That is true. So option A is correct. Microgrid typically relies only on the RE sources such as the solar, wind for their power generation. False, because you can have the other generating sources also like small hydro. Also, you can have the biomass also. Okay, so these kind of RE sources also you can add in the microgrid. Okay. Third is the primary purpose of a microgrid is to provide a reliable and stable power supply during the grid outages. Okay, so that is also correct because you can supply the power, so that it is required. Okay, D option it is a microgrid are mainly used in the urban areas have limited applicability. That is false because you can have a certain island. Suppose you can see in the right side figure, there you can use the microgrid concept to power the houses there. Okay, so it have the advantage in the rural and the remote location. E part advanced control system essential for optimizing the performance of microgrid and balancing the supply and demand. That is correct. Okay, so the correct is the A, C, and E. Okay, let's move further. Try to solve this problem. Try to solve this problem first, and then we will move to the last problem which I have given. Any answer? If you are finding difficulty in solving, just let me know. Okay. I will make sure that you should understand the problem first. Okay. Okay, let me give the solution for this. Okay. So you have the solar PV plant. It is selling. It have the inverter rated at 150 MVA. According to the grid code, the plant must be capable of operating anywhere between the 0.95 lakh to 0.95. It is like this. So you have a PV plant, okay, and it generally, okay, it's false. So it basically generate DC, okay. For the conversion, because grid which is required it AC, okay. So in between you mainly keep DC to DC converter, okay, to uplift the voltage which is there at a DC link capacitor here, and then you have a DC to AC converter, okay. Okay, it is fulfilling because you have to maintain a certain voltage to get the 230 volt and 50 hertz supply, okay, phase value. So for that sense you have to maintain a certain voltage level here at a DC link, okay. So this basically, this whole system, this is basically called as a plant, okay. Small scale plant, you have a single unit and it is generating, but in the plant you have a this kind of unit, multiple units can be there, okay. So it is selling, telling that it can supply the inverter rated at. So this inverter basically DC to AC converter. I'm considering this as a solar PV system. Okay. So this is S is equal to 105 MVA. It is given. Okay. And it is telling that it can supply in the both direction. Like it can provide the 0.95 lag also and 0.95 lead also. Okay. But here in the question, when you see, it is saying, can the plant inject the 100 megawatt while meeting this requirement? Okay. But the problem is that what is the maximum power you can get? Okay. So power is basically the S cos phi. Okay, S is basically 105 and the cos phi is the 0.95. Okay, so this, from this you can get the what is the value. Let's calculate 105. Let's multiply. See, 105 multiplied by 0.95. Let's calculate again. 105 multiplied by 0.95. 0.95, that is equal to 99.75. Okay, so this much capability it have. Okay, either you can see in the power will be here only, but reactive power will be the different. Okay, it can provide here in the positive form also, it can provide in the negative direction also, because it is having 0.95 lag also, it is having support from the 0.95 lead as well. Okay, so reactive power supply, how much margin remains? So this you can find it out by calculating the S values. Okay. So when you see the power here, power maximum is given 99.75. Okay. But the requirement, what is the requirement here is the 100 megawatt. But the plant, when you see here, it is supplying only 99.75 because the power factor maximum it hit it. Okay, so that's why this is the power max. So what is the deficit? Deficit is basically 100 minus 99.75, that is 0.75 megawatt. Okay, getting my point? So it is not able to meet the requirement because it is hitting the power maximum at a 99.75, but it is required to inject the 100 megawatt, but deficit is 0.75 megawatt. Okay, any problem in this? Anyone? If you're not able to understand, I will make sure that you should understand. Okay, is it fine? Just comment that okay, and that's correct. Reactive power is 32.77 MVAR. Okay, you just have to check that what is the P max here. Okay, when you get the P max, you can find it out what is the deficit is there. Okay, anyone who is not able to understand this problem, okay, I can explain it again if you want. Anyone? Okay, okay. So it means that you are able to understand the problem. So try to solve this problem. Okay, I got answer 519.62. Okay, let's others also to solve. Okay. Okay, let me give the solution for this. So this is a easy problem. Just you have to understand few things. Like it is being said that it is a 11 kV feeder. Okay, as a having a reactive demand of 450 kVr. So it's like this. You have a generating source. You have a certain feeder, and there is a load. Okay, so here it is saying the 450 kVr of required reactive power is there. Okay, but it is also said that a fixed capacitor bank of 15.8 microfarad remains connected. Okay, so now you are connecting a capacitor banks also, which is of 15.8 microfarad. Where you are connecting? You are connecting here at a 11 kV feeder only. Okay, getting my point? So you can find it out what is the reactive power support given by this. Okay, so this is will be 11 square multiplied divided by the uh, uh, 2 pi fc 2 pi. If your frequency is not given, assume it's 50 multiplied by 15.8 into 10 to the power minus 6. Here 10 to the power 6 it is there. Okay, sorry, here one error is there. So it will be like this: q is equal to v square by xc. So it will be v square omega c. So you have to multiply 2 pi f multiplied by c, that is 15.8 multiplied by 10 to the power minus 6. So when you find it out, you will get certain value. And it is like this. So you are providing a certain reactive power from the capacitor bank, but it was 40 kVr already. So what it to be seen from the source side? So it will be a minus of that, because if qc is greater than the 450, so it extra can go into here. If it is able to supply less than the 450, it means that it is going here. So you have to just subtract or add based upon the what is being seen from the source side. Okay, that is simple problem. You just have to see what is the qc value is coming, and it will supply some here. And if it is extra is being there, so you have to supply there. Okay, like this the problem is there. Okay, getting my point? So let's move further. Try to solve this last problem. Here, just remember that the ILR ratio, inverter loading ratio, this is basically DC capacity divided by the AC capacity. Okay, let's try to solve this. First find out the first, then second, third, fourth, like this. Read the problem thoroughly first. Okay, 75 megawatt total DC capacity. Okay, so that is correct. Okay, so it is when you see the total DC capacity of the plant, so ILR basically is equal to DC capacity by AC capacity. Okay, so AC capacity is given here. You can see 60 megawatt is there. So what is the DC capacity? DC is the basically 121.25 multiplied by 60. That is come out to be 75, I think. Okay, so it is coming out to be 75 megawatt. Okay, getting my point. Find it out the total number of PV modules required. That is correct. Why? Because when you see the total number of PV modules required, so PV module, one PV module, okay, so it is state care power level is of 550 watt. Okay, so the what is the power? Power basically VDC IDC. Okay, and the power which is already given here is the 550 watt. And what is the so power total is given as 75 megawatt. Okay, so the number of PV modules required will be such that 475 divided by this 550. Okay, find out what is the number of central inverters required. Okay, 20 is fine because 75 megawatt is the total and the 3 megawatt is the one. Okay, so the 3 megawatt basically, so this is basically one is of rated of a 3 megawatt. So it is the capacity because it's a 60 megawatt. So 60 divided by 3, that is 20. Okay, so 20 is the correct. So find out what is the DC capacity connected to each inverter. and also number of PV modules connected to each inverter. That's correct. That 3.75. Okay. So this is basically the 75 is the total capacity. 20 you have the total inverters. You just have to find out what is the DC capacity you will get the from each inverter. Okay. Number of PV modules you can also find it out because each module you know already the number of modules already to connect it to each inverter because 20 inverters are there, so you just have to divide it by the 20. Okay, try to solve it again by from your side. Okay, and try to revise all the stuffs which I have given in the tutorial session and also in the assignment which you have seen from the NPTEL side. Okay, so that's all for the 2 days. If you have any doubt, just let me know. Okay, you can ask if you want anything to ask before the exam. Okay then. So best of luck for your exam. Uh, try to do your best and try to revise all the stuff which I have given. And okay, you will get the all the question from the assignment and the tutorials only. Okay, there is nothing more than that. Okay. So there's a one question is the exam objective type. So actually, I'm not aware of the exam pattern because my job is just to solve your questions and the queries related to the technical side. Okay. So the coordinator you can email them and also you can ask the professor by email through email. Okay, and the paper mostly I can say that it is objective type what I have heard from the previous students. Okay, so this is mostly objective type only because it's a very difficult to give the subjective check the subjective answers. Okay, so expect only the objective part only. Okay, and some kind of like keep putting the some values like 100 or something kind of there can be some values like a git type. Okay, any other questions? Okay, number of PV modules here. So here the number of PV modules, let me erase it here. So number of PV modules connected to each inverter. Okay, so you get the number of inverters, central inverters equal to 20. Okay, and also you have got the total number of modules. Okay, from this question, from the second part. Okay, what you have to do, you have to just divide that total of number of modules divided by 20. Okay, you will get the from the single unit or single central inverter how number of modules will be connected. Okay, number, their number. Okay, you can give. Yes, this is the last tutorial session because I have already taken one revision session, and this is also continuation of that. So I have already taken nearly 12 classes plus one revision session. So 13 classes basically allotted to me for taking the tutorials. Okay. Any other doubt? Okay, then that's all from the my side. And it was a great session, and this was also a new learning for me as well. Uh, Solving the distribution side of the problem. Okay, so if you face any doubt further, and you can connect with the LinkedIn, and you can just type my name on the LinkedIn or Google. You can just find out my homepage there. Okay, you can directly connect to me and ask anything if you want related to exam or anything. Okay, so that's all for of this session basically, and thank you for joining here, and that's all from my side. Thank you so much.